Hi everyone, welcome to another video lesson for algebra. Today we'll be learning how to add and subtract rationals with common denominators. But before I go into the examples for adding or subtracting rationals, let me just give you a review from when you studied how to add fractions. So to be able to add fractions, you need to have the same denominator. All the fractions have to have the same denominator. So in this case, when that happens, all we do is add the numerators. So this is 1 and then plus 2, and then they have the same denominator of 5. So then you just add 1 and 2, which combine to 3, and this is 3 over 5, and this cannot be simplified, so this will be our answer for that problem. So it's the same idea with rational expressions. Okay, so the goal is to get you ready to solve rational equations, which will be the last concept you're going to learn this school year for algebra. So for example number 1, simplify each expression, state any restrictions on the variable. So simplify means add, subtract, multiply, do whatever you need to do. Okay, so in this case, notice that we have the same denominator in the two fractions or the two rationals. So then what I'm going to do is just like I did on adding these two fractions, I'm going to subtract 5 from 27, and this is over 11x. So then this is equal to 27 minus 5 is 22 over 11x. But then notice that 11 goes into 22 two times. So then this 22 becomes a 2 and this 11 becomes a 1, which is just x. So then this is equal to 2 over x. But don't forget, if we have a variable in the denominator, we must restrict the values of x. Okay, so in this case, x cannot be equal to 0. Because this will make the function undefined. Okay, so this will be the answer to this problem. And the next example, for this one again, we do have the same denominator of 4, which means we just combine the numerators. So then this is equal to 3x plus 8 over, they have 4 as denominator. So then combine 3x and 4 and 1x combined to 4x. Plus 8 over 4. But then you can either factor out a GCF in the numerator, or you can also see it as how many times 4 going to 8 and how many times 4 going to 4. So what I'm going to do is I'm going to factor out a GCF because that makes it more obvious. So then this becomes x, and 8 divided by 4 is 2. But then notice we have a 4 in the denominator. So then this 4 and that 4 reduce. So then this is just equal to x plus 2. Now about this problem, notice that there is no variable in the denominator, so there's no restrictions on the values of x for this one, okay, because we only have a constant there. So this will be the answer, so there is no restrictions for that one. So I'll just add a note here, and that note is that we have no restrictions because there is no variable in the denominator. Okay, so the next example, for this one here, again we have the same denominator, so then we just combine the numerators. So then this is x squared minus 4 over x plus 2. But then this here is a difference of squares. So we can factor this one out as x minus 2 times x plus 2 over x plus 2. But then notice we have x plus 2 and x plus 2, so we can cross those out. So then this simplified to x minus 2, but we do have a variable in the denominator. And in this case, we can have x equal to negative 2, because if that is the case, and this becomes 0, which is undefined. So x cannot be equal to negative 2. Okay, and that's all for this example. Example number 5. For this one, again, we have the same denominator, but notice that we have quadratic trinomial. So we need to factor that one out in a moment. Okay, so for this one here, I'm going to add t plus 5. And then we can factor this out as, so this will be t and another t here. Okay, so I'm gonna do it just for one of them because it's the same denominator. And then now we need to find multiples of negative 15 that when we add them give us a positive 2. So the only multiples of 15 that do that are 3 and 5. We need a positive 2 when we add them, so that means the 5 gets the plus and the 3 gets the minus. Okay, so then this factors as t minus 3 times t plus 5. And notice, again, both of them, this is the same denominator, so I don't have to do it for this one. It's the same thing, okay? So then I can cross out t plus 5. And then in the end, don't forget, this becomes a 1. Okay, so then this is equal to 1 over t minus 3. And then we have t minus 3 and t plus 5, which means t cannot be equal to positive 3, and for plus 5, negative 5. And this is the answer, along with restrictions to that example. Okay, last example. So for this example here, we do have the same denominator. So what I'm going to do is, I'm going to do a parenthesis here, okay, because this minus is going to change the sign of this 7 and that negative x. So which means I need to distribute that negative. Okay, so then this stays the same. So that's x minus 3, and then negative times, negative imply negative 1. Negative 1 times 7, that's negative 7. Negative times negative is positive, so this becomes positive x over x minus 5. And now let's combine like terms in the numerator. So then this is equal to this x and this x combined to positive 2x, and then negative 3 and negative 7 combined to negative 10 over x minus 5. But then there's a GCF, because 2 goes into 10 evenly, so I'm going to factor out a GCF of 2. So then this becomes x minus 5, 2 times x minus 5 over x minus 5. But notice again, these two, we can cross them out. So then in the end, all we have left is 2. But since we have a variable in the denominator, we have to restrict that value for x. And that value is that x cannot be equal to positive 5. So as you can see, I hope this is simple enough so that you follow each one of the examples. And I'll see you in class. Thank you for watching. Bye-bye.